Hello there, my name is Hui, and today we'll be discussing exothermic and endothermic reactions. But first, what is a reaction? A reaction is the process in which one or more reactants are converted to products. All reactions are controlled by two variables, kinetics and thermodynamics. Kinetics control the speed at which the reaction occurs, and thermodynamics determines if the reaction occurs spontaneously. The balance between these two factors determines the properties of a reaction. But today, we'll just be focusing on thermodynamics, or exothermic and endothermic reactions. For those who don't know yet, what is the difference between an exothermic and endothermic reaction? An exothermic reaction is a reaction that releases heat energy into the surroundings, but an endothermic reaction is a reaction that absorbs energy from the surroundings. So therefore, exothermic reactions feel hot and endothermic reactions feel cold. But why are exothermic reactions exothermic and endothermic reactions endothermic? It's because of bonds. Contrary to the belief of some, reactions are exothermic because of the formation of bonds, because when substances release energy, they become more stable. That is why most formation reactions are exothermic. And endothermic reactions are actually due to the breaking of bonds, because when energy is absorbed, they become less stable. That is why most dissociation reactions are endothermic. Here are two examples of thermodynamic reactions. Although not everyday reactions, these reactions include an everyday molecule in our lives, H2O, or more commonly known as water. Water can be decomposed by electrocuting it while it's in its liquid state. This reaction causes 2 moles of water to break into 2 moles of hydrogen gas and 1 mole of oxygen gas. Remember that hydrogen and oxygen are diatomic elements, so when they are in the gaseous state, they are found in pairs. To find the amount of energy absorbed from the decomposition of water, we have to calculate the overall bond energies of the reaction. Subtracting the total energy of the bonds formed from the total energies of the bonds broken, we can find the overall energy gain. There are 4 single oxygen-hydrogen bonds that are broken, while there are 2 hydrogen-hydrogen bonds and 1 double oxygen bond that are formed. After calculations, it shows that there are 482 kilojoules of energy absorbed from the reaction. The reverse of the dissociation of water is the formation of water, which also happens to be a combustion reaction. Finding the overall bond energies can be done by subtracting the energy of the bonds formed from the energy of the bonds destroyed. This reaction instead has 1 double oxygen bond and 2 hydrogen-hydrogen bonds that are broken, while there are 4 single oxygen-hydrogen bonds that are formed. From the calculations, it shows that there are 482 kilojoules of energy evolved from that reaction. Notice that the amount of energy it takes to form water is also the same amount of energy that it takes to decompose water. But instead, for a more everyday reaction, we would use reactions with sugar. Exothermic reactions using sugar molecules results in the formation of water and carbon dioxide. This reaction is used in the baking of cakes, or most commonly in the dessert of flan. An endothermic reaction using carbon dioxide and water results in a less complex sugar molecule and oxygen. This endothermic reaction is also known as photosynthesis. As you see, exothermic and endothermic reactions are everywhere, but it all depends on the bonds to determine if the reaction is truly exothermic or endothermic. And thank you for watching.
Created using Powtoon.